Okay, so now let's get into an investigation of resistance. And this is where it gets a little bit more complicated. So you want to make sure you do this sketch, pause the video now, and go ahead and sketch this out. And you'll see that really does help you when it comes time to doing the math. The math itself isn't that difficult, but figuring out when to do it and which numbers to put where sometimes gets a little tricky. So we'll start, as we always do, by reminding ourselves of the formula, which will be E equals I times R. Okay, and we're going to kind of play with that formula. We're going to twist it around, and we're going to solve for something other than E, because we already know what E is. It's 5. The voltage is 5. So what we're going to solve for will be the amperage at each of the resistors. So let's take resistor 1. So we're going to first of all come up with the amperage formula, which is going to be I equals E divided by R. And we got that by dividing both sides here by R. And we cancel those two guys, right? So we have I equals E divided by R. Okay, so let's solve it for R1. So we know that E is 5 volts. Okay, and we know the resistance is 10. And 5 divided by 10 is going to be 0.5 amps. Okay, now let's do the same thing over here. We're going to solve for the amperage at R2. Voltage is the same. We remember that. And in this case, the resistance is 10 ohms. So it's 5 divided by 10. And it's also going to be equal to 5 amps. Okay, so now we need to figure out the total amperage. Well, the total amperage in a system is what? Think about it for a sec. Okay, that should be enough time. We remember that the total amperage in a system like this, so if we call it I total equals I1 plus I2 plus I3 and so on. So it's a sum. So the total amperage in this case is 0.5 and 0.5. So the total amperage equals 1 amp. Make sense? As we did before, I'm going to go ahead and write the amperage at each of these points here. So the amperage here is 0.5. And the amperage here is 0.5. And we know what the total amperage is, right? Total amperage, and I'll put it down here, is 1 amp. Now I'm going to go ahead and erase the red scritzling. Okay, now let's figure out what the equivalent resistance or the total resistance is for this circuit. You would think, by looking at this, that it would be 20 ohms. Well, it's not, and this is what makes resistance a little bit more difficult than either voltage or amperage. So we're going to solve for resistance, so let's come up with the formula. So we're going to say that resistance equals voltage divided by amperage. Okay? So let's now solve for the total resistance. Okay, so we're going to start off with E, which is 5 volts. And we're going to divide it by the total amperage. And we're going to come up with a rather unusual number. We're going to come up with 5 ohms as being the total resistance. And here's where we run into a problem with the word total. It's really not the total resistance. The total resistance is obviously 20 ohms, but it's the equivalent resistance. Okay? In this entire circuit, this parallel circuit, with a voltage of 5 and an amperage of 1 amp, the equivalent resistance of these two resistors operating in parallel is 5, which means that it's not a sum, it's not a difference, it's not the result of division, and it's not the result of multiplication. It's something else entirely, and that's what we're going to discover. What I'm going to suggest is that we substitute a drawing now that will have the 5 volts for the battery and will have the equivalent resistor in the circuit, and that will be a resistor equal to 5 ohms. Okay, so here is a new diagram of what this would look like. Now you notice it's a series circuit, but the math should still be the same, especially if we use E equals I times R. And we're going to check for resistance. So that's going to be R equals E divided by I. So we know that E is 5, and we know that I is equal to what? So we have to switch back and take a look at our last diagram to see what the current was. And we can see from this the current was 1 amp. Okay, so let's go back. So if we put in the current at 1 amp, 5 divided by 1 is the resistance, is equal to 5, which, there it is. So we can see that there's kind of a funny thing going on where two 10 ohm resistors is equivalent to a single 5 ohm resistor. Now, that's just the way it is, but we'll take a look at the math that we can use to figure out resistance in various circuits. Okay, thanks for watching.